2 bricks, a fire you light once, and a room that stays warm for 18 hours. No gas line, no electric bill, no moving parts. That's not a magic trick. That's not a gimmick. That's thermal mass heating, and it worked for 10,000 years before someone figured out how to put a meter on warmth and charge you for it every month. Most people have never heard the term, and that's not an accident. What I'm going to show you today doesn't require a hardware store run, a YouTube DIY degree, or a second mortgage. You need bricks, the kind you can find in a crumbling garden wall, a construction dumpster, or for about $2 a piece at any home improvement store. You need a heat source you probably already have, and you need about 20 minutes to understand why this technique quietly disappeared from mainstream knowledge right around the time utility companies started stringing power lines across the country. Stay with me, because once you see how this works, you're going to wonder why nobody ever showed you. The average American household spent $1,400 on heating last winter, and most of that money went straight to companies that have zero interest in you ever needing them less. That's not cynicism. That's just how the business model works. A customer who heats their home for free is a customer who doesn't pay a bill, and customers who don't pay bills are, from a utility company's perspective, a problem. So think about what that means. Over a 30-year mortgage, you're looking at $42,000 in heating costs, conservatively. And every single winter, you have less control over that number than you think. Prices spike when demand spikes. When the grid goes down, your furnace goes with it. When natural gas supply tightens, your bill climbs whether you use more energy or not. Meanwhile, the technique I'm about to show you has been working in cold climates since before the Roman Empire. Peasant farmers used it. Medieval monks used it. Frontier homesteaders used it. Every culture that survived winter without centralized infrastructure figured out some version of this. And then, somewhere between 1920 and 1960, it just vanished from common knowledge. Why? Before the utility grid reached rural America in the 1930s, every farmhouse, monastery, and field hospital on Earth used some version of what I'm about to show you. The Kang bed in northern China, a massive brick platform heated from beneath, kept families warm through Manchurian winters that hit 30 below zero. The hypocaust systems under Roman bathhouses circulated heat through thick masonry floors for hours after the fires went cold. Scandinavian soapstone wood stoves, some of which are still standing today, were specifically engineered to absorb heat fast and release it slowly, warming a room for 12 to 16 hours on a single burn. These weren't primitive workarounds. They were refined, deliberate technologies developed over centuries of cold weather survival. Engineers understood, even without the vocabulary of thermodynamics, that certain dense materials absorb enormous amounts of heat energy and release it gradually, long after the original flame is gone. That property has a name now. It's called specific heat capacity, and dense-fired clay, ordinary brick, has one of the highest specific heat capacities of any common building material. Stone and cast iron are in the same family. All of them hold heat the way a sponge holds water, charge them up, and they keep giving it back long after the source is gone. So when did this stop being common knowledge? Right around the same time that electric baseboard heaters and gas furnaces became the default. When a new metered technology entered the home, the unmetered alternatives became inconvenient to talk about. They didn't vanish from physics textbooks, but they stopped showing up in home construction guides. They stopped being taught to new homeowners. The contractors who built post-war suburban houses weren't trained in thermal mass. They were trained in ductwork. Was there a coordinated effort to suppress it? That's a harder claim to make. What we can say is that an industry built on recurring monthly payment had every structural reason to prefer a system that creates recurring monthly payments, and the knowledge quietly faded. Here's how it actually works, and it comes down to one principle that your high school physics teacher probably glossed over. Dense materials, brick, stone, concrete, cast iron, absorb heat slowly and release it even more slowly. When you expose a standard clay brick to sustained heat for 2 to 3 hours, it absorbs roughly 200 BTUs per pound of thermal energy. A standard brick weighs about 5 pounds. Run the numbers. That's 1,000 BTUs of stored heat per brick, available to radiate into your living space for hours after the fire dies. 2 bricks, fully heated. 2,000 BTUs. That's not nothing. In a well-insulated 150 square foot room, that's enough to maintain a comfortable temperature for 6 to 8 hours. In a smaller space, a tent, a cabin, a single bedroom, you're looking at longer. Here's what you need. 2 or more dense clay bricks. Not lightweight cinder blocks, not hollow decorative bricks. Solid fired clay. A heat source. A wood stove, a fireplace. Even a charcoal fire safely contained outdoors. And time. Roughly 2 to 3 hours of sustained exposure to bring those bricks up to full thermal saturation. That's the whole list. No tools, no wiring. no special materials. Let me walk you through exactly what this looks like in practice, because seeing the numbers is what makes believers out of skeptics. Start by placing your bricks in or immediately beside your heat source. If you're using a fireplace, they go directly in the firebox on either side of the logs. Wood stove, same principle. Place them against the sides or on top if the surface is flat. You're not doing anything exotic here. You're just letting the bricks absorb what the fire produces. After about 90 minutes, you'll notice something. The surface of those bricks, if you hold your hand a few inches away, radiates a warmth that feels almost aggressive. Not hot to the touch dangerous, but deeply, steadily warm. The kind of warmth that a baseboard heater never quite produces because radiant heat from mass feels different than forced air. It warms surfaces, not just the air. At the 2-hour mark, use fire-safe tongs or heavy gloves to move those bricks. Wrap them in a towel, a thick one, to slow the surface release and make them safe to position near furniture, at the foot of a bed, or in the center of a small room on a fire-safe surface like tile or stone. 1 hour later, the room is noticeably warmer. 4 hours later, those bricks are still giving off gentle, consistent heat. 6 hours in, they're still warm to the touch. A single evening fire in a wood stove combined with 2 properly positioned bricks extends the effective heating window of that fire by 4 to 6 hours. Think about what that costs you. The wood you were already burning, 2 bricks, nothing else. Over a heating season, say 5 months, the supplemental heat those bricks provide could meaningfully reduce how often your furnace cycles on. Depending on your setup, that's a real reduction in monthly utility costs. Not a rebate, not a program, just physics, working for you instead of for a company. Before you go stacking bricks next to your fireplace tonight, a few things you genuinely need to know. 1. Not all bricks are created equal. Lightweight or hollow bricks won't store meaningful heat and can crack under thermal stress. You want dense, solid, kiln-fired clay brick. These are standard at any masonry supplier or home improvement store, and they're cheap. If you're pulling them from a demolition site, check for hollow centers before you use them. 2. Moving heated bricks safely matters. These things get genuinely hot. Heavy leather gloves, fire tongs, and a slow transfer process are non-negotiable. Always wrap them before placing them near fabric, wood floors, or anywhere a child or pet might make contact. On a tile surface or a purpose-built brick platform, they're perfectly safe. Directly on hardwood, don't do it. 3. This scales. 2 bricks is a starting point. A traditional Kang-style sleeping platform used hundreds of pounds of thermal mass to heat an entire family through the night. If you want to build a more serious thermal battery, a dedicated masonry mass inside a well-insulated room, the principle stays exactly the same, just larger. You can start small, prove it works for your space, and expand from there. The point is, you have options. Options that don't show up on a utility bill. 2 bricks and a principle that heated civilization for thousands of years, and it costs you nothing but the time to set it up. That's worth sitting with. Roman engineers understood thermal mass. Chinese farmers understood it. Scandinavian craftsmen built wood stoves around it that are still warming homes today. This knowledge wasn't lost because it stopped working. It was quietly set aside at the exact moment that a competing system, one that required monthly payment, became the dominant option. Now you know it again. Do 2 things. First, try it. Even just once, this winter. Get 2 solid clay bricks, let your next fire run for 2 hours, wrap those bricks, and watch what happens to your room temperature over the next 6 hours. Don't take my word for it. Test it yourself. Measure it yourself. Trust what you actually experience. Second, tell someone. A neighbor, a family member, someone who's been watching their heating bill climb every winter and wondering if there's anything they can do about it. This kind of knowledge spreads person to person, which is the only way it survived the last century at all. This channel exists for one reason, to find the techniques and principles that got buried when someone figured out how to monetize the alternative. There's more of it than most people realize. If you want to keep finding it, you know where the subscribe button is. Heat isn't complicated. It never was. 2 bricks, a fire, and a little patience, and warmth becomes something you generate, not something you purchase.